arithmetic progressions then. Here's an example of an arithmetic progression. If the progression has a common difference, it's an arithmetic progression. In other words, the difference between one term and the term next term is always the same difference, then it's an arithmetic progression. So D equals +2 in this particular case. It doesn't have to be a whole number, it can be a fraction, and it doesn't have to be positive, it can be negative. For example, this 2 is an arithmetic progression. Next term, right, and the common difference -5. So that's an arithmetic and geometric progression. If I add them up, so if I say, right, I'm going to add up these terms, first term, second term, third term, and so on, then it becomes a series. So 3 + 5 + 7 + 9 + 11 is an arithmetic series. 23 + 18 + 30 + 8 and so on is an arithmetic series. So let's just define some notation around these things. So let's look at this first arithmetic regression again. So look at 3, 5, 7, 9, 11. That's called the first term in the series. So let's have a bit of room here. So we say n for the term. So this is the first term, second term, third term, fourth term, and so on, up to the nth term. So the general name for any term in an arithmetic progression is called the nth term. So in this one, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and then n for the general one. An expression for the nth term is so the nth term is a plus n minus 1 lots of d. So therefore the 8th term in this sequence, or this progression, would be 3 plus n minus 1, which is 7 times 2. 7 2s are 14, plus 3, 17. So we should find, if we were to continue on with this sequence and we got to the 8th term, that would be 17. So if we want to know any particular term, we can work it out. The textbook takes you through how you arrive at an expression for the sum of a sequence of terms. So the series, the sum of the series up to the nth term. I'm just going to present you the expression and we'll look at using it. So the sum as far as the nth term is n over 2 brackets a, where a is the first term, plus n minus 1 times d, which is the common difference. So up here we should maybe make a note that this is the first term. So these two expressions, this one to find any particular term in a sequence, and this one to find the sum as far as the nth term, are useful. If we look at the example we have for our sequence, starting at 3 and going up in 2s, so for our example, what's the sum as far as the 8th term? It's going to equal n over 2, so it could be 8 over 2, open brackets, a, which is the first term, plus n minus 1, which is 7 times 2. So that's going to equal 4 times 17, which is 68. So if we were to add up all those numbers, starting at 3 and going for 8 terms, and added them together, we get 68. So if we look at this work problem 2 on page 117, so if we know what the 6th term is, and we know that what the 13th term is, we can determine the 19th term. So what do we do in this case? Well, the nth term of an arithmetic progression is given by that, a equals n minus 1d, which is a plus n minus 1d, which is what we've said. So we can write two different equations. A plus 5d equals 17, a plus 12d equals 38. Two simultaneous equations. Two unknowns, a and d, two equations. So we can solve those. This one's easy to do because a is the same in both. So we can just subtract equation 1 from equation 2 to get value for d, and then we can find a. So we can use these little formulae to find, say, the nth term, plus what we know already, solving simultaneous equations, to find solutions to problems involving arithmetic progressions. If you look at the first exercise that follows on for that, exercise number 60, which is on your exercise sheet, there are some introductory questions there. You could try some of those just to introduce you to the ideas of using arithmetic progressions. If I give you about 5 or 10 minutes, just have a look at some of those questions in there.